we can go ahead and get started. So good afternoon, everyone, and welcome to another PAMIC webinar. My name is Brittany Bargo, and I'm the Director of Communications and Technology at PAMIC. Now, today's webinar is titled Introduction to Stucco and Common Problems Associated with Stucco Systems, presented by Jody DeMarco, Vice President of Engineering at FCNA Partners. Now, before I really introduce our speaker, I just wanted to give a quick thank you to our sponsors, which are listed on your screen. Without them, our quality educational webinars just would not be possible. So thank you to our sponsors. Now, moving on to our presenter today, Mr. DeMarco has more than 30 years of engineering experience encompassing commercial and residential design and construction, roadway and highway design and construction, bridge design and construction, site and civil design, forensic investigations, litigation support, and expert testimony. Mr. DeMarco has investigated more than 100 stucco clad houses. Mr. DeMarco is the Vice President, of Engineering and of FCNA Partners, Inc. He is responsible for the engineering oversight of the company and preparation of all engineering documents. He performs engineering investigations and has provided expert testimony on more than 60 occasions. He has been court qualified and as an expert in civil engineering, structural engineering, and human factors. So that's just an introduction to our presenter today, and just a few housekeeping items before we begin. We ask that if you have any questions, please submit them through the Q&A block at the bottom of your screen. Additionally, if you would like to rewatch this presentation or would like to contact our presenter today, both will be hosted on the on-demand section of the PAMIC website after the conclusion of this webinar. Now, without further ado, Jody, I will hand the presentation over to you.
Thank you, Brittany, for that introduction, and thank you for the opportunity to give this presentation today. And want to thank everybody who is participating. As Brittany said, we are going to hold the questions until the very end. I'm going to ask for your forgiveness as I give this presentation. This is a brand new presentation. I've never given this presentation before. I might run a little bit short. I might run a little bit longer than an hour. So I just ask that you understand that the first time I give a presentation that's brand new, it's difficult to gauge how long the presentation will take. Like Brittany said, I'm the Vice President of Engineering for FCNA Partners. Looked at many stucco clad buildings and the problems associated with them. This presentation today is just an introduction. We could spend probably a full 8 hours discussing stucco, how stucco should be applied, the codes associated with stucco installation, and all of the standards. So what I tried to do today for this presentation is to provide you with the basic sections of the codes, the basic sections of the standards, some of the most common problems that we are seeing with stucco installations, and how we deal with them. And as we go through, I'll give you some stories of what we've seen out in the field and the trends that we're seeing when we have a bad stucco on houses. So today we're going to cover the codes and standards. Then we're going to shift to the components of stucco cladding systems. We're going to talk about the common problems associated with stucco. We're going to talk about the site investigations, probe testing, and destructive testing. We're going to talk a little bit about the extent of damage and the cost of damage. And finally, we're going to wrap it up with who's at fault and what we should consider when these assignments or cases go into litigation, how we could how we handle it, or what some of the considerations are. So we're going to just jump right into it. We're going to talk about the codes and standards. Now, these next few slides, I apologize, can be somewhat boring, but like anything, to talk about a subject, we have to understand the language and we have to understand the definitions of what we're talking about. So to use an engineering term, we need to lay the foundation here so we all understand what the terminology means. Basically, I'm going to be going over two things in the beginning of this presentation: the building code. And as you see on the screen, I have the 2012 International Building Code. And I did that deliberately. I deliberately cited the 2012 building code rather than the most current building code. And the reason is when we talk about stucco, most of the problems that we're seeing today with stucco are from construction that was maybe 8 to 12 years ago. So rather than talking about the code that's applicable today when something is built, I deliberately structured this presentation with language from the 2012 building code, since that's between 8 and 10 years ago. So that's what we're seeing right now, problems of buildings that were built in that time frame. So that's why the 2012 building code is cited here. So just to get into some of the definitions, when we talk about stucco backing, the wall or surface to which the veneer is secured. The backing is the portion of the structure that provides support for the veneer. And when I say the veneer, I'm talking about stucco. We could be talking about a stone, a man-made stone, but for the context of this discussion, when I say veneer, we're talking about stucco. The backing also typically resists lateral and transverse loads imposed by the veneer and may be load-bearing or non-load-bearing. The backing is basically on a typical wood frame house, we're talking about the plywood. Behind the plywood are the wall studs. You have the wall studs, the plywood, and then you have the cladding system, which we're going to go in very good detail talking about. The exterior wall envelope, a system or assembly of exterior wall components, including exterior wall materials that provides protection of the building structural members, including framing and sheathing materials, and conditioned interior space from detrimental effects of the exterior environment. So the envelope is basically the cladding system that keeps the interior from getting wet. 2012 building code further, chapter 2. These are the definitions. If you've worked on stucco cases or assignments, you've probably seen WRB, and WRB means water resistive barrier. And that's a material behind an exterior wall covering that is intended to resist liquid water that has penetrated behind the exterior covering and to prevent further intrusion into the wall assembly. So you might say, well, what does this mean? What this means is that stucco, it is anticipated that water will get behind the stucco. The codes recognize it, the standards recognize it. So knowing that some amount of water will get behind the hard surface stucco itself, the code and standards call for a water resistive barrier to be put behind the stucco. And I'm going to show you some details a little bit later that depict what that means and what that is. Some more of the code, chapter 25 of the code, gypsum board and plaster. In the codes and the standards, when they talk about stucco, it's typically not written as stucco. They usually call it plaster. More specifically, they call it exterior plaster to distinguish it from interior plaster. Interior plaster is usually made of gypsum, where exterior plaster is made and has to be made of a cement-based material. So section 2512.1, general, plastering with cement plaster shall not be less than 3 coats when applied over metal lath or wire fabric lath or gypsum board backing as specified in section 2510.5, and shall not be less than 2 coats when applied over masonry concrete. Cement plaster or stucco is the only type approved by the code for the use of exterior plaster finishes. So when you hear stucco, it means cement plaster. When you hear cement plaster, it means stucco. The word plaster, many people think of the interior of their house that may, older houses that may have plaster walls. We're not talking about that type of plaster. That's a gypsum based. We're talking about a cement based plaster. So this is a good diagram. It may be a little bit difficult for you to see, but this is right out of chapter 25 of the IBC. And it shows it basically shows the layers of stucco when applied to a gypsum board on the exterior. At the top of the detail, you see the studs. And then I'm going to just go down the left side of the page. You see the solid gypsum or the sheathing. That could just as well be plywood. The building paper, we're going to get into a lot of detail to talk about what that building paper or that WRB is. And then on top of that, you have the metal lath, and I'm going to show you pictures of what that looks like. And then on top of that, you actually have the 3 coats of stucco. Again, the cement-based stucco, which is screeded or troweled on or basically smeared on. And you have at the bottom of the page, you have what's called a weep screed. I'm going to tell you the definition of that. I'm going to show you pictures of that. And then, of course, you have your foundation and then your finished grade. This detail is right out of the building code. So when we talk to contractors and they say, well, you know, it's ambiguous or it's unclear what the codes and standards say about stucco, that may have been true 20 years ago. Now it's very clear. The codes and the standards are very clear on the application of stucco. A weep screed, we just saw that. I'm going to toggle back. If you see on this figure 2512.1 where the weep screed is, the weep screeds are water and moisture. It's understood that water and moisture can penetrate an exterior plaster wall for a variety of reasons and in a number of ways. It's expected that some moisture will penetrate the plaster in an exterior wall. Therefore, the design of a wall should include a weep screed, which will provide a way to release the moisture. In other words, if water gets behind the stucco for whatever reason, it should have a drainage field to follow, not being in contact with the wood, and it should drain right out of the bottom. Now, after I put this detail in, I realized that it may be difficult to see, but on the when we look at this detail, again, this is right from chapter 25 of the IBC. This on the left side shows the interior space of a house. You see where it says floor, I'm kind of circling that with my cursor. And then you see the wall studs, and then everything from here to the right is going to be the exterior, where you have your plaster or your stucco. Behind that, you have your metal lath. Behind that, you have your building paper. And then at the bottom of the wall, in the area that I'm indicating with my cursor, you have your weep screed. Any moisture that gets behind the stucco will flow down the building paper face. That's your drainage field, and will leak out through the weep screed. And you'll notice that there is a distance of between 2 and 4 inches between the bottom of the weep screed and the ground, whether it's paved or whether it's soil. And the reason is you do not want the stucco or the weep screed in direct contact with anything where water could wick upward. Chapter 14 discusses exterior walls. This chapter outlines the requirements for exterior walls of buildings, minimum standards for wall covering materials such as material performance, installation of wall coverings, and the ability of the wall to provide weather protection. Again, the codes are very well written now to account for stucco. Section 1403.2, weather protection. Exterior walls shall provide the building with a weather-resistant exterior wall envelope. The exterior wall envelope shall include flashing, as described in 1405.4. The exterior wall envelope shall be designed and constructed in such a manner as to prevent the accumulation of water within the wall assembly by providing water-resistive barrier behind the exterior veneer, as described in 1404.2, and a means for drainage or for draining water that enters the assembly to the exterior. And then I just go through those sections that I cited up here. The materials, water-resistant barrier, a minimum of 1 layer of number 15 asphalt felt complying with ASTM D226 for type 1 felt or other approved materials shall be attached to the studs or sheathing with flashing as described in 14054 in such a manner as to provide a continuous water-resistant barrier behind the exterior wall veneer. Later on in the presentation, I'll show you a few details of what that means. What I'm seeing in the field is nobody is using felt paper. They're basically using Tyvek. and the code and even Tyvek, their manufacturer material specs call for 2 layers of Tyvek. And I'll show you exactly how that is all installed a little bit later on. But again, we need to lay the foundation to show that the codes and the standards cover this very well. And if any contractor tries to tell you otherwise, they're simply not being truthful. Weather protection. Exterior walls shall provide weather protection for the building. The materials of minimum nominal thickness specified in 1405.2 shall be acceptable as approved weather coverings. And then section 1405.2, stucco exterior cement plaster, 3-coat over metal plaster is 7/8 inches. And that does not include the texture. In other words, that's measured from the backside to the front, but not the texture. And stucco over masonry is 5/8 thickness. Some more of the building code, 1405.4, flashings shall be installed in such a manner as to prevent moisture from entering the wall or to redirect it to the exterior. Flashing shall be installed at the perimeters of exterior doors and window assemblies, penetrations and terminations of exterior wall assemblies, exterior wall intersections with roofs, chimneys, porches, decks, balconies, and similar projections, and at built-in gutters and similar locations where moisture could enter the wall. So basically, wherever there is a hole in the sheathing, it has to have proper flashing. The big areas are the windows. Typically, what I'm seeing is the windows are the biggest problem areas. Sometimes the doors, but mostly what I'm seeing are many problems around windows. Now we jump from the codes to the standards. There are a couple standards that I'm going to refer to today. One is ASTM C 926-20. This is the standard specification for the application of Portland cement-based plaster. It covers the minimum technical requirements for the application of full thickness Portland cement-based plaster for exterior or stucco and interior work. Some of the terminology used, base coat is all plaster applied before the application of the finish coat. Brown coat, in a 3-coat work system, the 2nd coat applied over the scratch coat. In 2-coat work, the brown coat refers to the double up base coat. In either use, the brown coat is the coat directly beneath the finish coat. Really no reason to get hung up on brown coat, whether it's a 2nd coat or whatever. It should be 7/8 inch thickness. That's the bottom line. A little more from C 926, some more terminology. The scratch coat, the finish coat of plaster applied to a plaster base, a metal plaster base, expanded metal lath, or welded or woven wire lath. I'm basically seeing the expanded metal lath, or the basically that's what I'm seeing out there. And I'll show you some pictures of that a little later on, but we just have to get through what all the definitions are. Plaster is Portland cement-based cementitious mixture or stucco, and stucco is Portland cement-based plaster used on exterior locations. Now we jump over to ASTM 1861, which is the standard specification for lathing and furring accessories. This specification contains the minimum requirements for lathing and furring accessories and fasteners as components of the interior and exterior Portland cement-based plaster assemblies used to facilitate lathing and furring installations, cement plaster applications, and functionality of the complete stucco cladding system. Little more terminology from 1861. Case-bead, that's very important. Many houses that I look at do not have case beadings around the windows. I'll show you pictures of what it looks like when case beading is applied and what it looks like when case beading is not applied. So this is a pretty important definition. It's the lathing accessory used as a screed to assist in cement plaster thickness control, to separate cement plaster from dissimilar materials, and to provide an edge, an end, or termination for a cement panel area. So basically what this is saying, one of the big functions is dissimilar materials. we're talking about plaster, which is a cement-based material. And when that should not be put in direct contact with a wood window or a vinyl window. And the reason is the cement-based stucco and the window, whatever the composition is, expand and contract at different rates than each other. So basically, when you have dissimilar materials that expand and contract because of thermal movement, you have a gap that opens up, becomes wider and becomes more narrow. So basically, this case beading is something that is put in close proximity to the window, and it provides a break between the two dissimilar materials. That'll become a lot more clear when I show you the detail and the photo of what that case beading looks like. Next definition that's important is drainage surface is the sloped and non-sloped, perforated or non-perforated surface element of a lathing accessory that facilitates a drainage function by directing water from behind the stucco cladding to the exterior of the stucco cladding. Again, a couple minutes ago when we were talking about the Tyvek and the 2 layers of Tyvek, basically that's the drainage surface. Ground or screed, don't think of ground as like the floor or the soil. It's the element of the lathing accessory that provides an edge, an end or termination for a cement plaster panel. A little more terminology from Astm C 1861. Movement gap, the element of an expansion joint lathing accessory that accommodates some degree of movement in the stucco cladding assembly caused by the movement of the building, the substrate, or its components. It's understood that every building is going to move either by wind, from ground movement, or thermal expansion, where the materials expand and contract because of different temperatures throughout the day and throughout the year. It's understood that, that the cladding will also move, so a proper stucco design should include expansion joints to allow for the movement. Weep screed is the accessory located at the bottom of an exterior framed or framed and sheathed walls, used as a screed to assist in cement plaster thickness control, to facilitate drainage, and to provide an edge, end, or termination for a cement plaster panel area. Now you'll see weep screed and case beading. Some of that definition is the same in that they both provide the edge or the end of the termination of the stucco. So I took these next couple details right out of ASTM C 1861-20. This is basically what the standard shows us, the dimensions of what a weep screed should be. You could see that it's 3.5 inches minimum height, and the ground or dimension, the screed dimension, typically that's the thickness of the stucco, which is usually 7/8 inches on wood framed walls. And you could see it has holes in it or perforations that allow water to drain out. Here's a nice detail where my cursor is indicating this would be the plywood. You have your Tyvek, you have your metal lath, and then you have your brown coat, scratch coat, and finish coat of your stucco. Behind all of that assembly, applied directly to the wood, is the weep screed. So you can see the weep screed is one of the first items that gets installed even before, way before the stucco, and even before the weather or the water resistant barrier. And again, this should be a minimum of 2 to 4 inches above the ground level. And you could see the holes in the bottom where any water that gets behind the stucco and gets on the drainage field would simply just weep right out of the bottom of your weep screed. This is the case beading, which I said is so important around windows. Again, it talks about the ground dimension or the screed dimension. Again, this dimension is typically 7/8 inches. So they have this, the installer of the stucco can gauge how thick the stucco application is just by bringing it right up to the edge of this case beading. And this is what case beading looks like. On the upper left of the photo, we have a window. This white strip with all the holes in it, this is case beading. And if you could see near the bottom of the window, you could kind of see what the profile of the case beading looks like. Now, you might be asking yourself, or you might want to ask me, what is that dimension? Why is there a gap between the edge of the window and the case beading? And the reason is that is to allow for thermal movement of the window, which is going to move independently of the stucco once the stucco is installed. So this gap right here between the window and the case beading would be filled with what's called a backer rod. And that backer rod is simply it's basically a foam. It's almost like a miniature pool noodle. A piece of cylindrical foam is put in this gap, and then a heavy bead of good quality caulk is put on top of that backer rod. And between the backer rod and the caulk, that allows the stucco to move independent of the window and the window to move independent of the stucco. And the backer rod and the caulk allow for that movement. That is a wear and tear item over time that does need to be replaced, pulled out and replaced. But because there is a nice gap there, it's relatively simple to pull that backer rod and the caulk out. It all needs to be scraped clean and then, of course, reapplied. This next photo is a similar photo where we have a window frame. You can see the case beading is white. And then on top of the case beading, you could see the metal lath. And you could see the gap between the case beading and the window. Again, the backer rod would be installed between the two with the bead of caulk between the backer rod and the window. And you see the metal lath, which is applied, and the stucco would be applied to that. The stucco would be screeded on and would be pushed on by hand, and the stucco would grab onto that lath. And that's basically what gives what allows the stucco to adhere to the wall. Also, another function or another component taken right out of the ASTM is the control joint. When we talked about the movement of the stucco, how it's going to expand and contract, if you have a large wall, a wall that's more than 12 feet long, it should have an expansion joint or a control joint. Basically, this is a built-in joint in the stucco that allows for movement. Much like the case beading, it has metal lath on either side, and it has a V-shaped groove that's solid. Here's a picture of me holding one at a construction site. And again, when this is applied to the wall, in the middle of that expansion joint, a piece of foam would be put in there, and also caulk would be installed inside there. Now, typically, these expansion joints should be placed horizontally around vertically around every 12 feet, and in a vertical direction at every floor level. So if there's a second level, it should be at the floor level between the first and second. If there's a third, one should be installed between the second and third level. Sorry about that. Another important component is kickout flashing. What we have here shown in the light blue is a piece of kickout flashing. What we have is a roof system that's shown here in black gray, and it intersects with a vertical wall. And this type of situation can be problematic if step flashing is not installed. If step flashing is not installed, water has a direct conduit to go right from the roof to get behind the stucco. Many times when we look at houses, look at the corners of where the roofs intersect vertical walls. Sometimes you see like a black type or a green type of staining. Typically in those areas, no kickout flashing is present. When kickout flashing is present, you typically do not see that green or gray staining along the stucco. This is just another example of what a proper stucco installation looks like as it relates to the weep screed. You see you have your plywood, you have your 2 layers of water resistant barrier. In this case, where it's labeled number 4, the lath, this is more of a mesh. It's not metal, but it could be, but you get the point. Typically, I'm seeing metal lath out there. And then, of course, you have your weep screed. And you could see the concept that any water that gets behind the stucco has a drainage field to drain directly out of the bottom of the wall. I'm going to focus on Tyvek. I was a little reluctant to put and talk about Tyvek. I'm not a Tyvek salesman. I'm not endorsing Tyvek in any way, but I do see a lot of Tyvek out there in application. So in fact, every application I see Tyvek. So I thought it was worth mentioning how the Tyvek, the WRB, water resistant barrier, is installed. Always installed from the bottom upward, where the bottom roll of Tyvek is installed first, then the top roll is installed. There is a Tyvek gives specifications on how all of these joints should be overlapped. They should all be overlapped 6 inches. Tyvek sells its own brand tape, which is 3 inches wide, and that tape should be applied to all vertical and horizontal seams where Tyvek overlaps. I'm going to show you a little more detail about that, but just going back to this, you'll see if you look very closely, the numbers, there's a number 1, 2, 3, 4, 5, 6, and 7. These are basically components of the Tyvek system that should be used. Tyvek actually tells the installer how frequently to staple the Tyvek to the sheathing, the type of material to use, and things of that nature. So it's very well laid out. There's no mystery or guesswork how the Tyvek should be installed. So the water resistive barrier, which typically what I'm seeing is Tyvek, or the WRB, is dependent upon the ability of the facade to drain. When stucco is installed over wood-based sheathing, a water-resistive, vapor-permeable barrier with a performance at least equivalent to 2 layers of grade D paper or a layer of water-resistive barrier, which is separate from the stucco by an intervening layer. Basically, that just means 2 layers of Tyvek paper. Some of the most common problems that I see associated with stucco installations are the following: penetrations and kickouts not detailed or sealed properly, dissimilar materials not separated from stucco, like we talked about the windows and the stucco, they're different materials, expand and contract at different rates. Trapped water, like we talked about, the weep screed needs to be installed. Insufficient stucco thickness, improper installation of the water resistive barrier, and the lack of controlled joints. I have control in there twice. I need to edit that. This is an example of penetrations and kickouts not detailed or sealed properly. If you remember a couple slides ago when I was talking about the kickout flashing, this is that detail in real life. We have a roof that intersects with a vertical wall. In the corner, you could see the kickout flashing. You could kind of see the different strata of materials. You see the plywood, which in the upper part of the plywood where the cut is, the plywood's in good shape. And then you have a lot of rot under and just around where the kickout flashing is. Clearly, something went wrong with the installation of this kickout flashing and or the weather resistive barrier. This was taken a couple years ago at destructive testing that I attended. And you'll also notice the juncture between the shingles and the stucco. You'll see you have the case beading right there between the two. And you'll notice that the case beading and the stucco are almost or in very close proximity. It looks like in some places in contact with the shingles. That should not be. That case beading and the edge of that stucco should be up to 2 inches away from the roof shingles. This is an example of what can happen if case beading is not used between the edge of the stucco and the edge of the window. You can see in this application, the stucco was brought right up to the window. It has a very jagged edge. There is no case beading and there's no opportunity to put a backer rod and proper caulking in that area. Many times what I see is a contractor or someone will come in years afterward and apply caulk in this area, but it is such a jagged surface that caulk is pretty much ineffective. And since no case beading was applied and proper caulk was not applied, water has entered that juncture between the stucco and the window and has caused extensive rot on the plywood underneath the window. Trapped water. I took this photo many years ago. You could see the stucco bulging out. The parts of the stucco that I was able to remove by hand, the metal lath underneath it was completely rusted, and in some locations was non-existent because it had rusted all the way through. In this location, there was no way for the water to escape. The water was trapped. In addition to that, you could see that the treads of the stairs are actually embedded into the stucco, which is a big no-no, and it basically allowed water to enter behind the stucco. And without a weep screed, the water just stayed in that area and deteriorated the lath until the point where the stucco started to fall apart and disintegrate. One of the other problems, insufficient stucco thickness. Nominal plaster thickness for 3-coat work with metal plaster base or the metal lath is 3/8 inch first coat, 3/8 inch second coat, and 1/8 inch finish coat for a total of 7/8 inch thickness. Insufficient stucco thickness does not adequately cover and protect the metal lath and does not have sufficient strength to resist loads. Typically, you want the thickness to be 7/8 inches, and again with the dimension of the case beading and the weep screed, those are set at 7/8 inches. So the person applying the stucco has a guide to show them how thick the stucco should be. Keep in mind that you want 7/8 inch thickness for the structure, and also for the cycles of movement. A thinner type of stucco application will cool more rapidly and will heat more rapidly, and therefore experience more cycles of thermal movement, and therefore will be exposed to more stress and more likelihood of cracking. So that's why you want that mass of 7/8 inch thickness stucco to best resist all the cycles of thermal movement. This is an example. These next 3 slides show the proper installation of a WRB, or a water resistant barrier. Again, this is Tyvek, which I'm typically seeing out in the field. You could see it's, again, the bottom part would be rolled out first, and then the upper roll would be put on. You could see how it's cut out around the windows. A vertical slice is made in the middle of the window, and then it's folded back along the sides. You could see the bottom it's not folded over the bottom of the window opening. And at the top of the window, it's cut at 45-degree angles. You'll also see that the seams of where it's rolled and where it overlaps, they're taped, and that's 3-inch tape. And you could see the spacing of the staples, which I believe is supposed to be 18 inches on center. Now, the next slide is the next phase where the flashing is installed. The window is put in place. I did not put a picture in here in between this slide and this slide. On the bottom of the sill, there is a special flashing that is installed. When that's installed, the window is set, and then flashing is put around first the bottom portion of the window, and then the sides, and then finally on the top. And remember that Tyvek is still peeled up at the top. And then the next photograph shows the Tyvek roll down for at the top of the window. That's the proper way to install the first layer of the WRB. After that's installed, the second layer of the WRB would be installed, and basically that provides your drainage field. So any water that gets behind the stucco will have this field, and the water could roll down and drain out of the weep screed. Lack of control joints. Now, it's a little bit ironic. I talk about the lack of control joints, but this photograph shows control joints. I put this picture in deliberately to show that when control joints are put at the proper locations, they blend in nicely with the architecture and the aesthetics of the building. You could see there are several vertical joints, and at the floor lines, there are horizontal joints. You see them when you're looking for them, but if you're not looking for them, I don't believe that they take away from the look of the building. When control joints are not used, and typically the spacing is at every floor level, and typically no more than 12 feet in horizontal distance. When you get beyond that, the stucco is more prone to cracking. And of course, cracks lead to water getting behind the stucco. Water behind the stucco can lead to rusting of the metal lath. Rusting of the metal lath leads to deterioration, and ultimately the deterioration of the stucco itself, to the point where it can start bulging and falling off of the building. So, if there are suspected problems with the installation of stucco, some people or some attorneys hire companies to go out and conduct probe testing. And they prepare very extensive reports where they basically drill 2 holes at the bottom of each window, and they put a moisture meter, which has 2 metal prongs, and they penetrate the stucco through the drilled holes until they encounter the plywood, and they measure the moisture content of that plywood. And this is just one that I copied out of one of the reports that I have. And you could see 7%, 8%, 10%. In the lower part of the building, you'll see some that are up to 15%. So that's all nice to know. You get these reports. But what you also have to know is what these numbers translate as. This next slab kind of gives you the key for that. Moisture readings between 8 and 14% are not a problem. These readings are common to construction grade air dried lumber and healthy residential structures. So anything 14% or lower, it's totally fine. 16 to 19% readings indicate possible elevated levels of wood moisture. Such reading should alert the homeowner to look for a source of excess moisture. The excess moisture source should be corrected if found. Now, when we start getting to 20% and above, that's when we should start to be concerned. These readings indicate serious problems. Like I said, typically around windows, which is why when an investigator looks at these, they typically drill right below the windows. And the reason is because of that case beading is oftentimes missing. Sometimes the installation of shutters, when they are installed, after all the stucco is installed, sometimes the installer of the shutters will drill right through the stucco and right through the weather wrap, and you can get high readings on the wood because of those. So basically, anything 20 or above is cause for concern. One other thing on this slide, typically when you read these reports, they'll say S, which indicates a soft substrate, which typically means that the plywood underneath the lath and underneath the WRB is completely deteriorated, where the probe is not hitting anything; it's going straight into the wall. So using the probe testing can give an indication where there are problems. If our problems are identified, the next level is to conduct destructive testing. And destructive testing involves the removal of stucco to determine the extent of damage and the degree of damage. Once the extent and degree of damage is determined, cost estimates can be prepared. Probe testing itself, will only give us an idea where the problem areas are. And depending on when the last time it rained or what the conditions are, it does not tell us the extent or the degree of damage. Only destructive testing will tell us that. You kind of get a glimpse of it from this photo. Destructive testing is a very big project. It involves the installation of scaffolding. There is usually a protocol that's prepared. And typically at these destructive testings, there are several attorneys, experts with those attorneys, and the work crew. This destructive testing usually goes on for a period of several days, and it's all to determine the extent and degree of damage. Here's another photo from destructive testing that I attended. This shows some case beating, and it shows that Tyvek wrap. I just thought it was important to show you this. Actually, on this photo, you could see that the plywood is pretty clean, that there is no water, at least directly adjacent to this, this window. And here's a close-up photograph of a window corner with the case beading at along the side of the window and at the bottom of the window. You can see the multiple layers of Tyvek, and you can even see the Tyvek tape, which I'm peeling back right there to reveal the lower level of the Tyvek. And of course, you could see the plywood underneath all of that. By this point, all of the metal lath was removed. So when improper stucco is discovered, who's at fault? I can't give you an answer to that right now. Each situation is different. It's important to understand that various contractors and subcontractors may have been involved in the construction of the building, and a review of the contracts, if available, should be conducted. If contracts are not available, if the work was done by handshake or just because the general contractor was familiar with the work of some of the subs, which is often the case, then it's important to talk to the contractor that you insure or that you represent to get a very good understanding of what their work was. And sometimes that involves asking hard questions and probing at the contractor to ask them what work they were responsible for and what work others were responsible for. Ask them to go back to their diary notes if they have them. Ask them to go back to their photographs if they have them, because sometimes the memories are flawed, especially if there is a problem with the stucco. Some of those contractors could include a framing contractor, roofing contractors, stucco contractors, the window installer, the window manufacturer, the caulking contractor, or the installer of the water resistive barrier. So knowing who you represent, who your client is, and knowing what their role is and their function in relation to the roles of the other contractors is extremely important, because it's not always the stucco contractor who installs the water resistive barrier, and it's not always the framer who installs the windows. And sometimes the windows themselves are a problem of the leak, but that's kind of beyond this discussion, the testing of windows themselves. So there is no answer until we really start digging into the particular problem to answer those questions. So I'm getting toward the end of the discussion, and but when there is a problem, we always want to know who is at fault. We don't necessarily know, but a couple items that I wanted to put out there and maybe open up for discussion is to consider the Statute of Repose. The Pennsylvania Statute of Repose effectively eliminates the cause of action 12 years after the completion of construction of an improvement to real property. What this means is typically after something is built, the contractor or his subs or her subs could be on the hook for up to 12 years. If it goes beyond 12 years, you may not be able to point to the contractor or the subs. So that always becomes a discussion point especially when we talk about stucco, because stucco problems typically do not manifest themselves in year 1 or year 2 or even year 5. Typically, it takes 8 to 10 years and sometimes more to realize there is a problem with the stucco. Sometimes we're involved in cases where it's very close, where the contractor may have installed the stucco about 10 or 12 or 13 years ago. And in those situations, it's important to consider, and this is what I want to open up to discussion, when does the clock start ticking for the statute of repose? Is it at the issuance of the certificate of occupancy for when the first people moved into the house? Or is it at the time of substantial completion, which is defined as when the project or a portion of the project is fit for its intended use? So, so those are some important considerations for the statute of repose. I think we're pretty good on time. We've got about 5 or 10 minutes left for questions. If anybody has any insight or has any experience with the statute of repose and these open-end topics that I brought up, I welcome your comments and your insight. If not, open it up and bring it back to Brittany to see if any questions have come in during our presentation.
Perfect. Thank you so much, Jody. And we actually do have some more questions here. Now, again, to come across these, if anyone else does have questions, please submit them through the Q&A block and we will be sure to answer those for you. So the first question here is, should underwriters mostly be concerned with stucco installed prior to 2012 and assume if installed in compliance with 2012 codes, the risk is mostly mitigated?
So again, the 2012 was just the code that I referred to. If it's in Pennsylvania, again, take a look at the statute of repose. If a house is, or if the stucco was installed on the house more than 12 years ago, typically it cannot go back to the contractor. If it is less than 12 years ago, it can. But to dig into that a little more from an underwriting point of view, some of the most common features that we discuss, the case beating, the expansion joints, and the kickout flashings. A simple drive-by of the property, these elements are very obvious. No destructive testing is required to look at a house from the street to see if it has expansion joints, vertical and horizontal. No destructive testing is required to see if kickout flashing is present. You might have to get a little bit close to the windows to see if case beating is present, but all of these things could be done visually. Now, does that guarantee that water is not getting behind? Not necessarily. However, if those elements are not present, if expansion joints, vertical and horizontal, are not present, there's a good chance that the stucco is cracking. If kickout flashing is not present, there's a very good chance that water is getting behind the stucco right near the gutter. If case beating is not present, there's a very good chance that water is getting in at the seam of the window and the stucco. So a simple drive-by inspection or a walk-up inspection can give you a pretty good idea of the quality of the installation, but it won't necessarily tell you the full story. It'll just give you an idea of the quality of it. I'm not sure if that answered the question, so I just want to put this out there. All of this is available by PDF. You can reach out to me or Tom from my office. We'll be happy to answer questions that I did not fully answer during this session. And we're happy to give you the presentation or any of the details or any of the ASTM standards that may be helpful for you. So that's the best I could do with that question. Brittany, you said there's a couple more?
Yes. So the next one here kind of goes along the same lines. It's, what is the black staining often found on the stucco? Is it cosmetic or a structural issue?
If it's extensive, it is structural. Basically, the sheathing is typically OSB, oriented strand board, and you'll probably hear the term delaminating, or when it starts to peel apart. that's when it becomes structural, when the actual strands of the board start to peel apart. It becomes structural. There are varying levels, varying degrees of the deterioration and the water damage. Sometimes we see light staining where the wood is still in good shape. Many times we see the plywood or the OSB delaminated, peeling apart, and sometimes with large holes in it where it's providing no support. So it's both, and it's everywhere in between.
Looks like another one here. Can problems with installation be rectified by subsequent addings of flashings or screeds or groundwork?
Sometimes, yes, but again, it really depends on the extent of damage, which, in other words, if a probe testing is conducted and you find that you have something above 20% below a window, and destructive testing is conducted and that plywood is in pretty good shape, in other words, it's not delaminated, it just has some staining on it, in that situation, yes, the stucco, it can be reapplied, it can be repaired. If the plywood is so severely damaged where it's delaminated or there's holes in the plywood, then the answer would be no. What I'm seeing, the trend I'm seeing lately is that homeowners and their attorneys and experts are being more aggressive with the destructive testing, where they're peeling, in my opinion, in some cases, unnecessarily peeling stucco off of houses to fish around to see where the extent of damage is. And in many situations, what I've seen is the plywood is actually in pretty good shape. There may be minor damage below some windows, but again, in my opinion, it does not necessarily justify the complete tear off of the stucco. But that is the trend that I'm seeing, and it's something real that we have to deal with. And that's the way the plaintiffs or the attorneys or their experts are dealing with it.
Okay, so it does look like we have a couple more here as well. So how reliable is probe testing?
In my opinion, probe testing is very reliable. I've done it myself. Every time I've seen one of those probe testing reports and the destructive testing that follows it, they always fall in direct alignment. I have a lot of faith in the probe testing, but that again is just the first step to identify if there is or is not a problem. Again, to determine the extent of it, some cutouts have to be made.
Okay. Does mildew buildup on the stucco surface indicate there is a moisture issue behind the stucco, or is this strictly a cosmetic surface issue?
That's a great question. Sometimes yes, sometimes no. It really depends the orientation of the house, how much it dries out. I think you'd have to look at that. If there is a part of the house that never gets sunlight, if it's always in the shadow or in the dark, that could be just surface mildew that can be washed off. However, if it's in an area that does get direct sunlight that should be drying out, then it could be probably is a indication that moisture is getting behind the stucco and not properly draining. And you typically see that if you look at the front of a house and it gets direct sunlight and you see brown or green staining at the corners of the windows, or if you look at a part of the house where there's an overhang and there's a gutter, and if there is brown or green staining, just look right above that to see if there is kick-out flashing. If there's not kick-out flashing, it's almost a guarantee that water is getting in at that juncture between the wall and the roof. So it's a case-by-case situation, and it could be different on the same house, depending on the exposure to the sun and how much it dries out.
Okay, well, that looks like it is about all the time we have here. If you have more questions for Jody, please remember that his contact information will be provided, as well as a recording of this webinar on the on-demand section of the PAMIC website. So thank you very, very much, Jody, for that informative presentation. As a reminder as well, just for keepsakes here with PAMIC, the first in-person event in over a year and a half, our 114th annual convention is next week. So if you have registered for that, we look forward to seeing you all there. Just again, thank you very much for Jody and FCNA for hosting this presentation, and I hope you all have a great rest of your day.
Thank you, Brittany.